What are some good conductors of electricity?
In order to be an effective conductor, a material must allow the electrons to move easily throughout it. The atoms in good conductors, such as most metals, have one or two electrons that can be easily freed from the nucleus to move through the material. Water is a fair conductor, but when salt is added it becomes a better electrical conductor.
Why does a prism separate light into a spectrum of colors?
If all wavelengths of light were refracted by the same amount when entering and leaving a prism, then there would be no separation of colors. The refractive index of all materials depends on the wavelength of light. In diamond the refractive index for blue is 1.594, for red 1.571. In flint glass the index varies from 1.528 to 1.514. In crown glass the variation is from 1.528 to 1.514. While in water it is only 1.340 to 1.331. In all cases the refractive index of blue is larger than that of red. So the blue light is refracted through a larger angle than the red. The large difference in diamonds accounts for their flash.
What important contributions did Nikola Tesla and George Westinghouse make in the late 19th century?
Nikola Tesla, 1856 to 1943, worked for Edison's company in Europe. Edison offered Tesla a large sum of money if he would invent an improved generator. When Tesla did, Edison refused to pay, saying he had been joking. Tesla quit. In 1884 George Westinghouse, 1846 to 1914, a prolific American inventor and businessman, formed the Westinghouse Electric Company. In 1884, 4 years later he persuaded Tesla to join his company and purchased his patents from him. Westinghouse had improved a transformer invented in France. But Tesla's AC induction motor, invented in 1883, and three-phase generator were essential for Westinghouse's dream of transmitting electric energy efficiently over long distances.
How do you convert from one scale to another?
Use the conversion chart below to convert between Celsius, Fahrenheit, and Kelvin. From to formula Celsius Kelvin degree C equals K plus 273.
What is a secondary rainbow?
Reversed color spectrum caused by an additional reflection of the light inside water droplet.
What was the first concert hall to be designed by an acoustical physicist?
Boston Symphony Hall, designed by physicist Wallace Clement Sabina, 1868 to 1919. Is the first concert hall designed specifically to enhance the sound of an orchestra. Sabina, who designed the hall in the late 1890s, discovered the relationship between sound intensity, absorption, and reverberation time. Sound reflections can either enhance or ruin a sound. Sabina discovered that having strong reflections immediately after a sound was produced would enhance the acoustics. But if sound was reflected midway between the source and the listener, it would detract from the acoustics because the time of travel would be significantly different. Sabine's Boston Symphony Hall, built in 1900, established an excellent reputation for sound quality. Mostly due to the choices of sound absorption materials as well as the strategic placement of reflecting material. The goal was to use the sound reflecting materials, high % reflection ratios, to create strong initial reflections, while using sound absorbing materials, low % reflection ratios, to absorb most of the energy from sound that would ordinarily reflect off of the high ceiling and the side walls in the rear of the hall. In 1973, Mr. Avery Fisher contributed over $10 million to support a complete reconstruction of the hall, and the hall is now named after him. The changes improved the acoustics, but the large stage reduced the loudness of bass sounds and the initial reflections were still too strong. Curved surfaces on the stage made of extremely tight grain maple would have improved bass problem, and reflectors consisting of 30,000 dowel rods were installed on the side walls. Except for classical music concerts and opera, most performances use electronic amplification. Loudspeakers can be located throughout the hall, and their response to different frequencies can be adjusted to compensate for shortcomings in the hall. The signal to speakers far from the stage can be delayed, so sound from all speakers arrives at the same time. Further, these changes can be adjusted so that the hall has the best acoustics for any type of use.
What is a white light?
The combination of all the colors in the visible spectrum.
How is the friction between two surfaces characterized?
In most cases, the frictional force is proportional to the force pushing the surfaces together, N. This proportionality is usually written as friction equals mu asterisk N. The Greek letter U, mu, is called the coefficient of friction. It is important to remember that the two forces, friction and N, are not in the same direction.
Does Benjamin Franklin's definition of positive and negative agree with today's understanding of charge?
Franklin decided that sparks given off by an object charged by a glass rod, vitreous electricity, looked more like fluid leaking out than did the sparks from an object charged by a rubber rod, resinous electricity. Thus he decided that glass had an excess of electrical fluid. Today we know that electric charge is mostly carried by electrons. Electrons are charged the same way that rubber or plastic is, negatively. Thus we say that they have a negative charge. Because they are transferred much more easily than are the more massive, positively charged nuclei. When there is an excess of electrons, the object is negatively charged. When there is a lack of electrons, it is positively charged. So even though Franklin made the wrong choice, we still follow his convention.
What is the R value?
Measure of resistance of material to heat transfer. R is the inverse of conduction, R equals 1/U.
What is acceleration, A?
Change in velocity divided by the time over which the change occurs, vector.
Which one goes faster?
You probably found that the one without the added mass sped up more. That is, for the same force, the greater the mass, the less the acceleration.
What is a generator?
Converts mechanical to electrical energy.
How is the pressure of a gas similar to liquid pressure?
The pressure from a gas acts the same way liquid pressure does. One difference between gaseous and liquid pressure is that gases are about 1/1000 as dense as liquids and therefore apply less pressure. The second difference is that gases can be easily compressed while the compressibility of liquid is very small.
What is the dark energy?
Said to be cause of accelerating expansion of universe. Comprises 72% of mass and energy of universe. Its nature is totally unknown.
What is medium frequency, MF, waves?
Frequency 300 kHz 3 MHz. What is a megahertz? Megahertz, dash 1 million hertz.
What is absolute zero?
Temperature at which molecular motion is at a minimum.
What is medical physics?
Study of how physical processes can be used to produce images of the inside of humans, as well as the use of radiation and high-energy particles in treating diseases such as cancer.
Why is it often cooler to wear white clothes, rather than black clothes?
White surfaces reflect all the colors of the rainbow, whereas black absorbs all the colors in the light spectrum. The absorption of this energy heats the black material, increasing its temperature. This, in turn, increases the temperature of the air between the clothing and the person. So white, which absorbs much less radiative energy from the sun, is cooler in hot climates.
How does Einstein's special theory of relativity affect momentum?
The same factor, y, that affected distance and time, affects momentum in the same way, that is relativistic momentum is ymv. Gamma is 1 at slow speeds and becomes large only when the velocity is near the speed of light.
What is Carnot efficiency?
Largest efficiency that a heat machine can obtain. E equals, thought, cold, / thought. Cathode negative electrode or terminal on, E. G a battery, electrolytic cell, or cathode ray tube.
Could antimatter destroy the Vatican?
In Dan Brown's novel Angels and Demons, physicists at CERN use the LHC, the Large Hadron Collider, to produce 1/4 gram of antimatter. The material was stolen in order to destroy the Vatican. It is true that if 1/4 gram of antimatter were to completely annihilate with 1/4 gram of matter, the amount of energy produced would equal that of the bomb that destroyed Hiroshima. But, in over 10 years of experimental production, only 10 million antiprotons have been trapped and stored for times ranging from seconds to months. 1/4 gram is 1016 times as many antiprotons. Further, the antiprotons must be stored in extremely cold. Totally, antiprotons are created in accelerators, where the accelerated particle is slammed into a metal target, emitting gammas that create, in this case, proton-antiproton pairs.
What is the fastest aircraft?
just like Chuck Yeager's Bell X-1, which was the first plane to break the sound barrier. The X-15A2, the fastest aircraft ever built, was dropped from the belly of a B-52 bomber. When released, the XI-5A2's rockets ignited, taking it to a maximum speed of 4,534 miles per hour. That speed, which is equivalent to 7,297 kilometers per hour, is Mach 6. The X-15 series flew 199 flights before being retired in 1969. The State Route 71, Blackbird, was the fastest known aircraft that can take off under its own power. It was retired in 1998.
Is there a difference between work and energy? Between heat and thermal energy?
Energy, whether kinetic, stored, or thermal, is a property of an object. Gravitational field energy is a property of the gravitational field. Work and heat are means of energy transfer. Work is transfer by mechanical means. Heat is transfer between two objects with different temperatures. Examples of work are you throwing a ball, a slingshot launching a stone, a ball being caught in a mitt. Examples of heat are your hand being warmed by putting it in hot water. A bottle of soda being cooled in a refrigerator, and Earth's surface being warmed by sunlight.
What is an open circuit?
A circuit is a closed loop through which electric charges can flow. If the loop is opened, then it is called an open circuit and charges no longer flow. A switch is commonly used to open and close a circuit. If a wire breaks, the connection between the wire and another part of the circuit fails. Or if a lamp burns out, its filament breaks, then the circuit is opened and there is no current.
Who discovered superconductivity?
The creation of materials without resistance was thought to be impossible. But a Dutch physicist by the name of Heike Kamerlingh Onnes, 1853 to 1926, proved it was possible in 1911. Onnes lowered the temperature of different metals, including mercury, close to absolute zero. He then measured the electrical resistance of the materials at such low temperatures and found that mercury, at only 4.2 Kelvin, minus 277.2 degrees Celsius, had zero resistance to electrical current.
What is colorimetry?
Because the perception of color is mostly a neurophysiological function between the eyes and the brain. It can vary slightly from person to person. Further, the subtractive color seen depends on the light source. If you plan to paint a room, you should examine the color when illuminated by several different light sources. Sunlight, light from incandescent lamps, and light from fluorescent lamps. The colors may look very different. They will even look different in the sunlight at noon versus that near sunset. Scientists, artists, advertisers, and printers need an objective method of specifying color as it relates to the frequency of light.
Who would become the most influential scientist of the 20th century?
On March 14, 1879, Albert Einstein was born in Ulm, Germany. No one knew that this little boy would one day grow up and change the way people viewed the laws of the universe. Albert was a top student in elementary school where he built models and toys and studied Euclid's geometry and Kant's philosophy. In high school, however, he hated the regimented style and rote learning. At age 16 he left school to be with his parents in Italy. He took, but failed, the entrance exam for the Polytechnic University in Zurich. After a year of study in Arras, Switzerland, he was admitted to the university. 4 years later, 1900, he was graduated. He spent 2 years searching for a job and finally became a patent clerk in Bern, Switzerland. During the next 3 years while working at the patent office he developed his ideas about electromagnetism, time and motion, and statistical physics. In 1905, his so-called Annus Mirabilis or miracle year, he published 4 extraordinary papers. One was on the photoelectric effect, in which Einstein introduced light quanta, later called photons. The second was about Brownian motion, which helped support the idea that all matter is composed of atoms. The third was on special relativity, which revolutionized the way physicists understand both motion at very high speeds and electromagnetism. The fourth developed the famous equation E equals mc2. While these papers completed his PhD requirements, it was 2 years before he was appointed a professor at the German University in Prague.
What is a concave mirror and what is it used for?
A concave mirror is curved inward so that the incident rays of light are reflected and can be brought together. If the rays striking the mirror were parallel to each other, as they would be from a distant source, then the reflected rays converge at the focal point. Concave mirrors are typically used to focus waves, whether it is a microwave signal to a receiver or light to an observer. They can produce real images. If, however, the object is closer to the mirror than the focal point. As is often the case with a concave bathroom mirror, the image is virtual and upright. If you look at the reflection of a more distant object, like the bathroom wall, you'll notice that it is upside down, or inverted. The wall is farther away from the mirror than the focal point, and its image is real. A point. Therefore convex mirrors form virtual images. Convex mirrors are used for security purposes in stores because they broaden the reflected field of vision, allowing clerks to see a large section of the store. The images are smaller than the objects, but the mirrors help to see a wide area.
What is the cause of rolling friction?
Rolling friction is the result of deformations of either the rolling object or the surface. Think about how much faster a rolling ball stops on grass or sand than on a hard surface. In those cases the ball has to push down the surface in front of it, which acts the same as contact friction. Or, remember when you rode a bicycle with soft tires. In this case the tire is squeezed when it contacts the street, which also acts like friction.
Why is noise pollution dangerous?
In the past, noise pollution was only thought to create health effects if the intensity was large enough to cause hearing damage. Studies over the past several decades, however, have found that long-term exposure to noise can cause potentially severe health problems in addition to hearing loss, especially for young children. Constant levels of noise, even at low levels, can be enough to cause stress, which can lead to high blood pressure, insomnia, psychiatric problems, and can even impact memory and thinking skills in children. In a German study, scientists found that children living near the Munich airport had higher levels of stress, which impaired their ability to learn, while children living further from the airport did not seem to experience the same problem.
How does the human eye see?
The eye is really an extension of the brain. It consists of a lens to focus the image, an iris to regulate the amount of light entering the eye, and a screen called the retina. The cells of the retina do some preliminary processing of the information. They receive then send signals along the optic nerve to the brain. The cornea is a transparent membrane on the outer surface of the eye. Between the cornea and lens is a fluid. Light refracts when going through the convex surface of the cornea into the fluid. In fact, most of the focusing of light in the eye occurs at the cornea. Light passes through the iris that opens and closes in response to the amount of light entering the eye. The iris can only change the amount of light to a going through it by a factor of 20. While our eye can respond to differences in light level of 10 trillion. The major task of the iris then can't be to control light intensity. In addition, when the opening in the iris shrinks, the eye can keep objects in focus from a wider range of distances. After passing through the iris, the light goes through the lens. The lens consists of layers of transparent fibers covered by a clear membrane. In order to focus in on objects that we want to see, our eye changes the shape, and thus the focal length of the lens and cornea by contracting or relaxing the ciliary muscle around the eye. Light then passes through a liquid called the vitreous humor. That fills the major volume of the eye and falls on the retina. The cornea and lens have created an inverted image on the surface of the retina. The retina is composed of a layer of light-sensitive cells, a matrix of nerve cells, and a dark backing. There are two kinds of light-sensitive cells, cones and rods. The 7 million cones are sensitive to high light levels and are concentrated around the fovea. The part of the retina directly behind the lens. Surrounding it are some 120 million rods that are sensitive to low light levels. The entire retina covers about 5 square centimeters. There aren't 127 million nerves in the optic nerve that goes to the brain. So a system of nerves in the retina do some preliminary processing of the electrical signals produced by the rods and cones before sending the results to the brain.
What is carbon dating?
Method of dating objects by measuring relative amounts of radioactive and stable carbon in them.
What happened at Kitty Hawk, North Carolina, on December 17, 1903?
It was on this date that brothers Orville, 1871 to 1948, and Wilbur, 1867 to 1912, Wright warmed up the engines on their Wright 1903 Flyer and took off into the blustery winter air. On its first flight, Orville flew the Flyer for a total of 12 seconds and traveled a distance of 37 meters, 120 feet. Later that cold winter day, Wilbur flew for nearly a minute and traveled 260 meters, 852 feet. The Wright 1903 Flyer, which weighed only 600 pounds and had a wingspan of 12 meters, 40 feet, made only 4 runs that day.
What is aerodynamics?
Aerodynamics is an aspect of fluid dynamics dealing specifically with the movement of air and other gases. Engineers studying aerodynamics analyze the flow of gases over and through automobiles, airplanes, golf balls, and other objects that move through air. They also study the effect of moving air on buildings, bridges, and other static objects.
How can you construct your own Leyden jar?
You can use either a glass or plastic container that has a tight-fitting cap. Use a small nail to make a hole in the center of the cap. Straighten a paper clip and push it through the hole. Make sure the end of the clip reaches the bottom of the jar. Cover the outside of the jar with aluminium foil and fill the jar about 2/3 full of water. Make sure that the jar cap is dry. Now rub a plastic pen with wool and touch the pen to the paper clip. Repeat the rubbing and touching several times. Then touch the clip with your finger. You should feel a very tiny shock. The jar has stored the charge that you gave the pen when you rubbed it.
Who discovered what makes an object hot?
Benjamin Thompson, Count Rumford, 1753 to 1814, who was born in the Massachusetts Bay Colony, but did most of his scientific work in the Kingdom of Bavaria, now part of Germany, deserves most of the credit. Before his experiments, most scientists thought that hot objects contained an invisible fluid called caloric. Experiments done before Rumford showed that when you heated an object it didn't gain weight. So caloric must be weightless as well as invisible. This result made many scientists suspicious of the caloric explanation, or theory. In 1789 Rumford drilled holes in bronze cannons through which a cannonball would be shot. He found that both the cannon and the metal chips that resulted from the drilling became hot. He determined the amount of water that could be raised to the boiling point by both the cannon bodies and the chips and showed that the caloric theory did not agree with his results. He finally concluded that in hot objects the particles that made up the material moved faster than they moved in cold objects. Using our present terminology, they had more kinetic energy. In their motion they vibrate back and forth, they do not move together like a thrown ball.
How is an eclipse a shadow?
An eclipse is created just as any other shadow, by the presence of an object in the path of light. In a lunar eclipse, Earth blocks the sun's light illuminating the moon. In a solar eclipse the moon keeps the sun's light from reaching Earth. Thus the shadow of the moon on Earth is what we call a solar eclipse.
What is a parasitic drag?
Force when an airplane wing, automobile, or any other object moves through a fluid.
What happens to the momentum of the ball and you and the chair all together?
As long as external forces are zero or small, then in any interaction the momentum of the system, in this case the ball, u, and the chair will be constant. This result is called the conservation of momentum. The sum of the decrease in momentum of the ball and the increase in momentum of you and the chair will be 0.
What is the Van Allen belt?
Donut-shaped regions of charged particles around Earth, created by charged electrons and protons from solar wind and cosmic rays trapped by Earth's magnetic field.
What is a sublimation?
Change of state from solid directly to gas.
What is a superconductor?
Superconductors allow electrical current to travel without resistance, and therefore no voltage drop across them or energy loss within them. Superconductors must be cooled below their critical temperatures to have no electrical resistance. Some elements, compounds, and alloys that are superconductors are lead and niobium nitride, and a niobium titanium alloy. All these require liquid helium to cool them to their critical temperatures. In the 1980s, some ceramics were found to have much higher transition temperatures that could be reached using much cheaper liquid nitrogen. The first found was yttrium barium copper oxide. As of 2008, a family of materials including iron, such as lanthanum oxygen fluorine iron arsenide, was developed.
What is Bernoulli's principle?
In 1738, a Swiss physicist and mathematician named Daniel Bernoulli, 1700 to 1782, discovered that when the speed of a moving fluid increases, such as the wind blowing through the corridors of a city, the pressure of that fluid decreases. Bernoulli discovered this while measuring the pressure of water as it flowed through pipes of different diameters.
What is the Système International, SI?
The International System of Units, based on the meter kilogram second, MKS, or metric system.
What is a circuit?
Circular path through which charge can flow. Needs a source of potential difference, wires, and a device with resistance.
What is a kilohertz, kilohertz?
(1000 Hz).
How does this very small gravitational field keep the Moon in its orbit?
The answer, of course, is that the Moon has a large mass. 7.2 x 1022 kilograms, and so the force on it is 2.0 x 1020 n. When we explore orbits later, we'll use this result.
What is the fastest aircraft?
Just like Chuck Yeager's Bell X-1, which was the first plane to break the sound barrier. The X-15A2, the fastest aircraft ever built, was dropped from the belly of a B-52 bomber. When released, the XI-5A2's rockets ignited, taking it to a maximum speed of 4,534 miles per hour. That speed, which is equivalent to 7,297 kilometers per hour, is Mach 6. The X-15 series flew 199 flights before being retired in 1969. The State Route 71, Blackbird, was the fastest known aircraft that can take off under its own power. It was retired in 1998.
What is the principle of relativity?
The laws of physics are the same in two coordinate systems. Moving at constant velocity with respect to each other.
What are atoms?
Smallest piece into which an element can be divided and retain its properties.
What are the advantages of the Hubble Space Telescope?
The Hubble doesn't have a mirror as large as the new Earth-based telescopes. But being in space, it is not limited by the distortions caused by variations in the refractive index of air above the telescope. In addition, a space telescope can detect the infrared and ultraviolet rays blocked by Earth's atmosphere. Other space-based telescopes are designed to detect X-rays and gamma rays from extremely energetic stars and galaxies.
How much resistance do our bodies have to electrical current?
On average, the human body has an electrical resistance between 50,000 and 150,000 ohms. Most of this resistance is across the skin. If the skin is wet, the resistance drops to about 1000 ohms. If the skin is broken, then resistance across organs in the body is on the order of a few hundred ohms. In this condition, 10 volts is sufficient to cause serious, if not fatal damage.
What makes up dark matter?
Many candidates have been proposed, but there is no agreement at this point. Neutrinos with mass could make up a small portion, as could brown dwarf stars that have failed to ignite. More likely candidates are the supersymmetric particles described above. Much discussion recently has focused on WIMPs, weakly interacting massive particles. If they exist, they would be passing through Earth, and so several experiments are underway to detect them. Early results from one experiment claim to have detected 2 particles. Other experiments look for indirect evidence from gamma rays or antimatter. One result claimed to have found an excess of positrons, but not antiprotons. The composition of dark matter is one of the most active areas of investigation in astrophysics.
What materials are effective absorbers of sound?
Different materials will absorb certain frequencies of sound better than other frequencies. But some of the best absorbers of sound are soft objects. Materials such as felt, carpeting, drapes, foam, and cork are good at matching the impedance of a sound wave and reflecting back very little sound. Materials such as concrete, brick, ceramic tile, and metals, on the other hand, are effective reflecting materials of sound. That is why gymnasiums, with hardwood floors, concrete walls, and metal ceilings, have relatively long reverberation times, while concert halls furnished with upholstered seats, carpeted floors, and long drapes have relatively short reverberation times. People are also effective sound absorbers. So a full concert hall has different acoustic properties than an empty one.
How was the laser invented?
One of the useful applications of quantum mechanics is in each CD or DVD player in your home, or in the laser pointer. It's the device that uses stimulated emission of light predicted by Einstein so many years ago. In 1953, Charles Townes, 1915, of Columbia University, and later MIT, developed and patented the first application that he called a maser for microwave amplification by stimulated emission of radiation. It used a beam of ammonia molecules and later led to the hydrogen maser, now used as an extremely accurate clock. In 1958, Townes and Arthur Shallow described how molecules could be used to extend the maser concept to optical frequencies. After their paper was published, a number of physicists at university and industrial labs rapidly tried to apply these ideas to working devices. In May 1960, Theodore Maiman, 1927–2007, at Hughes Aircraft Company demonstrated an optical maser that used a ruby crystal with a flash lamp. Similar to the camera flash lamp, to put the chromium atoms in the ruby into their excited states. Maiman was involved in a court fight over the validity of his patent for the laser with Gordon Gould. 1920 to 2005, who worked with towns at Columbia. In 1973 Gould was awarded the patent rights. Maiman won number of awards, but never the Nobel Prize. While the laser was first described as a solution looking for a problem. Over the past 50 years lasers have become a multi-million-dollar industry. Lasers have been constructed using gases, as in the familiar helium-neon, or He laser. The carbon dioxide laser used to cut fabrics and metals, the argon-ion laser used in surgery. The ultraviolet excimer laser used for eye surgery, and the free electron laser used in research. Lasers made of tiny semiconducting crystals are used in CD and DVD players and laser pointers, as well as optical fiber communications equipment that brings video and the internet almost to your front door. Lasers have revolutionized research in physics, chemistry, and biology.
What are vocal cords?
Or vocal folds. Vibrating source of the human voice.
How can the refraction of light be determined?
The extent to which a beam of light bends when it hits a different medium depends on the indices of refraction of the medium as well as the medium from which it came and the angle at which the light strikes the boundary between the two media. All materials have an index of refraction that depends on the speed of light in the material. The index of refraction is the speed of light in a vacuum divided by the speed of light in the material. A vacuum has a refractive index of 1, water is 1.33, and glass is around 1.5. The higher the index of refraction, the more slowly light travels through the medium. Snell's law of refraction, named after Dutch physicist Willebroord Snellius. 1580 to 1626, tells us how light behaves at a boundary between two different media. Consider the interface between two media where the refractive index of the top medium is lower than that of the bottom medium. According to Snell's law, when light hits the boundary between two materials it is bent from its original path to a smaller angle with respect to the line perpendicular to the surface of the interface. As the incoming, or incident angle increases, so does the refracted angle. When light goes from a medium with a higher refractive index into one with a lower index, then it is bent away from the line perpendicular to the surface.
When were lenses first made?
The word lens comes from the name of the lentil bean because of the similarity in shape of the bean and a converging lens. Lenses have been used for over 3,000 years. It's possible that ancient Assyrians used them as a burning glass to start fires. A burning glass is mentioned in a play by Aristophanes written in 424 BCE. Roman emperors used corrective lenses and knew that glass globes filled with water were able to produce magnified images. Al-Haytham Al-Hazan, 965-1038 CE, wrote the first major textbook on optics. That was translated into Latin in the 12th century and influenced European scientists. Shortly thereafter, in the 1280s, eyeglasses were used in Italy. The use of diverging lenses to correct nearsightedness, myopia, was documented in 1451. Today, lenses used in eyeglasses and cameras are usually made of lightweight plastics that are cheaper and more durable than traditional glass lenses.
What happens if you get close to a charged Van de Graaff?
The sphere on the Van de Graaff is a conductor surrounded by an insulator, the air. While there are strong forces on the negative charges on the sphere, they're not strong enough to break down the insulating properties of the air. If, however, you bring another object with less negative charge close to the generator, the forces on the air molecules can become strong enough to rip them apart, separating their negative electrons from the positive nuclei. A spark will jump. If that object is your finger, you'll feel a shock when the charges carried through the spark move through your body. While the shock can be painful, one produced by the kind of Van de Graaff in physics classrooms is not harmful.
What is a DC circuit?
In a DC, or direct current, circuit charges travel only in one direction. The voltage source, a battery or direct current power supply, has one positive and one negative terminal, so there is current in only one direction.
What is medical physics?
Study of how physical processes can be used to produce images of the inside of humans, as well as the use of radiation and high-energy particles in treating diseases such as cancer.
What is the coefficient of friction?
Friction force divided by normal force.
What is a center of gravity?
Depends on how weight of extended object is distributed. The object's motion is the same as that of a point object in which the gravitational force that acts on its center of gravity.
What is the closest fusion reactor?
The Sun. In stars like the Sun, the principal reaction is called the proton-proton cycle. That was first described by the German-American physicist Hans Bethe. 1906 to 2005, in 1939. In the first step, two protons fuse into a deuterium, 2H, nucleus. The deuterium has a proton and a neutron, so the second proton changed into a neutron, releasing a positron and a neutrino. The positron annihilates with an electron, producing two gamma rays. In the second stage, the deuterium fuses with another proton to produce helium-3, 3He, plus a gamma ray. In the Sun, the third stage is primarily a fusion between two 3He nuclei producing 4He plus 2 protons. So the net reaction is an input of 4 protons and an output of 2 4He plus 6 gammas and 2 neutrinos, as well as a lot of energy due to the loss of 0.7% of the mass of the protons. In order to accomplish these reactions, the protons must be moving with a large amount of kinetic energy, the equivalent of a temperature of about 10 million kelvins.
What is a volt, V?
Unit of measurement of potential difference or voltage.
What is luminous intensity?
I. Response to intensity of light electromagnetic waves.
What is a greenhouse gas?
Gases transparent to light and short-wavelength infrared radiation, but are opaque to the long-wavelength infrared emitted by warm objects. Examples are carbon dioxide, methane, and water vapor.
How did chemistry contribute to the acceptance of atoms?
Robert Boyle, 1627–1691, an Irishman who wrote The Sceptical Chymist in 1661. Is often considered the father of chemistry. He held that matter was made of atoms or groups of atoms that were constantly moving. He urged chemists to accept only those results that could be demonstrated by experiment. The great French chemist Antoine Laurent de Lavoisier, 1743–1794, demanded that measurements be made with precision and that scientific terms be clearly defined and carefully used. With the discovery that air contained oxygen, which is necessary to support animal life, he clearly demonstrated that air was not an element, but a mixture of oxygen and nitrogen. By showing that hydrogen, discovered by Henry Cavendish, 1731–1810, when mixed with oxygen formed water. Lavoisier showed that water also was not an element, but a compound of two elements. Lavoisier's care with weighing both the reactants and products of reactions allowed him to make one of the Earliest statements that mass is conserved, that is, neither created nor destroyed in chemical reactions. Lavoisier's wife was a brilliant woman who assisted her husband in many ways, including translating letters from foreign scientists. He was executed during the French Revolution for being a tax collector. In supporting the guilty verdict, the judge said the Republic needs neither chemists nor scientists. Lavoisier met with Joseph Priestley, 1733–1804, shortly after Priestley discovered oxygen in 1774. Lavoisier did extensive work on oxygen and gave it its present name. Priestley invented carbonated water and experimented with ammonia and laughing gas, nitrous oxide. But when he opposed much of the work of chemists of his generation, he was pushed to the sidelines. After writing theological books that opposed traditional Christianity in England, he was forced to flee to America in 1794. John Dalton, 1766–1844, was an English chemist who, because he was a Quaker, could not obtain a position in a state-run university. For a number of years he taught at a college in Manchester for dissenters from the Church of England. His strengths were his rich imagination and clear mental pictures, but especially his astonishing physical intuition. His first interest was meteorology. He wondered how Earth's atmosphere, consisting of gases of very different densities, could have the same composition at different altitudes. His meteorological studies led him to the conclusion that atoms were physical entities and their relative weight and number were crucial in chemical combinations. Dalton's atomic theory of chemistry was published in A New System of Chemical Philosophy in 1808 and 1810. Briefly, it has 5 parts. Elements are made of tiny particles called atoms that cannot be divided into smaller particles. Nor can they be created or destroyed or changed into another kind of atom. All atoms of an element are identical. So there are as many kinds of atoms as there are elements. The atoms of an element are different from those of any other element in that they have different weights. Atoms of one element can combine with atoms of another element to form a chemical compound, today called a molecule. A compound always has the same relative numbers and kinds of atoms. In a chemical reaction, atoms are rearranged among the compounds, they are neither lost nor gained. The first and last parts give an atomic basis for Lavoisier's conservation of mass that he had confirmed in many careful experiments. 2 of Dalton's specifications are now known to be false. Atoms can be changed from one kind to another by the process of radioactive decay. Not all atoms of an element have the same weight. Both of these results will be discussed in the chapter At the Heart of the Atom.
What does Kepler's third law tell us about the motion of satellites around Earth?
Kepler's third law relates the period of a satellite to its distance to the center of Earth. The table below shows the mean radius of the orbit, the altitude above Earth's surface, and the period for some typical satellites. Weather satellites have polar orbits so that the view of their cameras sweeps across the entire surface of Earth many times each day. The Moon's orbit is aligned with Earth's orbit around the Sun, not Earth's equator. Kepler's third law holds for satellites about other planets and for planets revolving around the Sun. But you need either Newton's laws or Einstein's relativity theory to explain these results.
What is a fuse?
Protects household electrical circuits are protected by fuses or circuit breakers. Opens when current exceeds a predetermined limit.
What is a concave mirror and what is it used for?
A concave mirror is curved inward so that the incident rays of light are reflected and can be brought together. If the rays striking the mirror were parallel to each other, as they would be from a distant source, then the reflected rays converge at the focal point. Concave mirrors are typically used to focus waves, whether it is a microwave signal to a receiver or light to an observer. They can produce real images. If, however, the object is closer to the mirror than the focal point. As is often the case with a concave bathroom mirror, the image is virtual and upright. If you look at the reflection of a more distant object, like the bathroom wall, you'll notice that it is upside down, or inverted. The wall is farther away from the mirror than the focal point, and its image is real. A point. Therefore, convex mirrors form virtual images. Convex mirrors are used for security purposes in stores because they broaden the reflected field of vision, allowing clerks to see a large section of the store. The images are smaller than the objects, but the mirrors help to see a wide area.
How do skydivers and parachutists use air drag to control their speed?
Skydivers can change their body shape, and thus their terminal velocity, by extending their arms, or separating their legs. Parachutists can tilt the chutes to control the direction in which they're falling.
But who made it and where?
It is uncertain, but likely to have been made in one of the colonies of Corinth on the island of Sicily. Perhaps by a student of Archimedes decades after he was killed. One method of creating a pulley with a variable diameter is to use a V-shaped belt and a pulley with a groove that can be adjusted in width. This kind of transmission is often used with hybrid cars, and is being developed as a means of decreasing fuel use.
What is the difference between a dead load and a live load?
In order to remain static, bridges, and all structures, for that matter, must be able to withstand loads placed on them. A load is simply the engineering term for force. Dead load is the weight of the bridge or structure itself. The live load, on the other hand, is the weight and forces applied to the bridge. As a result of the vehicles and people that move across the bridge at any one time. Of course, in order to be safe, engineers account for much higher live loads than would normally occur.
Why is helium used inside airships instead of hydrogen? Isn't hydrogen more buoyant?
Although hydrogen is twice as buoyant as helium, and would be more effective in lifting an airship off the ground, hydrogen gas is extremely dangerous. The German airship, or Zeppelin, the Hindenburg, the world's largest airship at the time, was destroyed on May 6, 1937, in Lakehurst, New Jersey, when it exploded into a huge fireball while attempting to land. 36 people died in the explosion. In 1937, the United States was about the only source of helium in the world, mostly from one gas well in Texas. The Nazis wanted to buy helium for their Zeppelins, but the United States refused to sell it to them as it was considered a strategic resource. Helium is formed from the radioactive decay of uranium and thorium in rocks. It is used today to cool devices and make them superconductive. As a result, the amount of helium available is rapidly decreasing.
What is a longitudinal wave?
Wave and its energy move in the same direction as direction of oscillations.
Why do astronomers believe there is dark matter in the universe?
The first hints that there is more to the universe than visible stars and galaxies came in 1933 when the Swiss-American astronomer Fred Zwicky, 1898–1974, studied the motion of galaxies in the Coma cluster and estimated that in order to account for their rapid motion there must be 400 times as much mass as could be accounted for. In the 1970s the American astronomer Vera Rubin, 1938, studied the rotation of galaxies and found that at least half of the matter in galaxies must be invisible dark matter. Dark matter is also in evidence in gravitational lensing, where the gravitational interaction of mass with light causes the light from very distant galaxies to be bent by nearer galaxies. The result is a distortion of shape and position in the images of the distant galaxies as if they are being seen through a lens. In one set of colliding galaxies the center of mass, determined by the lensing effect, is separated from the center of optical and X-ray brightness, probably by the effect of the collisions. Radio and infrared emissions from the initial Big Bang that formed the universe is called the 3 Kelvin cosmic microwave background radiation. Understanding the details of this radiation also requires large amounts of dark matter.
What conditions must be met in order to see a rainbow?
There are two main conditions for witnessing a rainbow. The first is that the observer must be between the sun and the water droplets. The water droplets can either be rain, mist from a waterfall, or the spray of a garden hose. The second condition is that the angle between the sun, the water droplets, and the observer's eyes must be between 40 degrees and 42 degrees. Therefore, rainbows are most easily seen when the sun is close to the horizon, so the rays striking the droplets are close to horizontal.